So it turns out that this concept of the Coulombic force that we've been talking about is useful when we're talking about point charges or very low quantities of charges. But as the number of charges that we're discussing or that we're considering increases, then it becomes more important to talk about things like fields. And for example, in this example that I have here, let's just say that this region here is a positively charged region, and we can see that I've left some holes there for maybe those are atoms that can accept an electron or something of that nature. But let's just say that this region has a positive charge of plus 3e, which is 3 times the fundamental charge, E, again being 1.602 times 10 to the minus 19 coulombs, right? So that's the charge of this region. And then let's just say that this region over here, where these electrons are sort of floating, has a charge of minus 3e, right? So this, what's called a charge imbalance, would give rise to an electric field. There would be an electric field. Of course, we know around this, here, let's just switch over, around this positively charged region pointing outward away from it in all directions. And then similarly, there would be an electric field pointing inward in all directions toward the negatively charged region. Again, just to recap, the electric field is defined as the force that would act on a test charge that's positive. So again, if I have a positive charge, of course, in the presence of a positively charged region, that positive test charge would be repelled. If I had a positive test charge in the region of a negatively charged region, that charge would be attracted. And so it's important to note that if I just kind of zoom in and take a look at the arrows here, there's a net electric field between these two regions pointing out from the minus terminal, or sorry, out from the positively charged region and into the negatively charged region, just like this. And what that means for a positive charge is that it would be, repelled away from the positive region. But for a negative charge, that means that it would be attracted towards the positive region, okay? And so in the next slide, that's sort of what I'm showing here, is that these charges, assuming they're free to move around, and assuming that this larger, heavier, more massive positive region is not free to move around, then these charges would move. They would actually move, and they would fill in the holes in that positively charged region. And so, like we said originally, we had a plus 3e charge on the positive region and a minus 3e charge on the negative region. Well, once those 3 electrons move, over here I have plus 3e plus a minus 3e, which becomes 0. And that would be a net neutral region at this point, because the electrons will have filled in the holes and there's no more charge on that region. That's kind of why I drew it as gray. And so what would be happening on the other side is I had negative 3 electrons, right? And I lost those 3 electrons. Sorry, I lost those 3 electrons charge, and so the net would be 0, and now this region would also be neutral. And so this is what's actually occurring when we have circuits and electricity. It's the flow of these electrons that's occurring. Originally, there was a misunderstanding of what was actually happening that could be interpreted similarly, and that would be if I had plus 3e, a charge of plus 3e, and I lose those 3 positive charges, I could also get to net neutral. And on this side, if I had a charge originally of minus 3e and I add 3e, I also get to net neutral. And so when we get into talking about conventional current flow versus electron flow, we're going to talk about why, if I have a circuit, let's just draw, I know we haven't seen any circuits yet, but let's just say I have a voltage source and a resistor. We haven't seen these yet. Current flow is defined as the current flowing out of the positive terminal and into the negative terminal of a battery. But that's not actually the way that electrons flow. Electrons flow from the minus terminal around back to the plus terminal. And so the reason why we originally defined current flow in the other direction is because there was a misunderstanding. There was a fundamental misunderstanding and an assumption that the plus charges or the positive charges were actually what was moving, and it was later discovered that it was the minus charges that were moving. And so I just wanted to cover that briefly. In the next video, I'm going to just show a little bit more about what happens when we have even more charges and why it's important to think about these fields and what's happening, because the next thing that we're going to talk about after that is voltage and current and resistance. And it's important to just get a visual of this movement of charge and what exactly a voltage source is doing and how it provides a constant voltage.